Welkom bij een nieuwe aflevering van de Nederlandse Kubernetes Podcast. De podcast over Kubernetes voor iedereen. Ik ben uw gastheer Ronald Kers en zoals altijd is met mij...
Ik ben Jan. Maar
Vorst. Ja, inderdaad Jan. Aangenaam.
Aangenaam. Hey, weer geweldige gasten. Het blijft maar doorgaan.
Ja.
En het zonnetje schijnt buiten ook. En ik weet niet wanneer deze uitkomt, maar het zonnetje schijnt en ik zie de Eiffeltoren hier vandaan.
Mooi hè?
Ja. Heel klein stukje overigens.
Ja, de Eiffel Tower is beautiful.
Ja.
I think I guess can agree with that.
I see a little part of the Eiffel Tower. Haven't been in Paris yet, but we're recording all the way.
Yeah.
So, but yeah.
So to introduce our guests, we have Daniel Finneran. Yeah, pronounced it correctly. Yeah. Okay. And Nicolas Vibert.
That's right.
Okay. Thank you guys joining from Isovalent. For the people who don't know you yet, and can you introduce yourselves to our listeners? And I will start with Daniel.
Hi, yes. So my name's Dan Finneran. I'm part of Isovalent. I'm a principal community advocate. So what that actually means is I spend my time helping the community get knowledge and experience around things like eBPF, Cilium, Kubernetes networking, all of that sort of area, really.
Okay. And Nicolas?
Hi everyone, I'm Nicolas Vibert. Also work at Isovalent. I'm a senior staff technical marketing engineer, which
That's a full man.
one of the longest titles in the industry. I've been at Isovalent almost 2 years now, and my role is not that different from Dan's. It's really about educating, teaching people about Cilium. I focus maybe less on community and eBPF, but more around creating content, videos, tutorials, online labs to get people up and running with Cilium.
Okay.
Cool.
What is Cilium for people who don't know it? I cannot imagine people using Kubernetes that don't know Cilium yet, but can you explain a little bit what Cilium is?
Yeah, absolutely. So Cilium, at its kind of most basic level, is there to provide networking functions in a Kubernetes cluster. So I was finding it amusing that most people, a lot of people, I guess, don't really realize that Kubernetes doesn't do a lot out of the box. It doesn't have any networking, doesn't do any storage. You need to kind of add a bunch of components to get the full experience. And yeah, networking is kind of paramount to how Kubernetes clusters actually work. And Cilium is there to provide that networking. So allowing pods to speak to other pods, allowing services to speak to pods that sit underneath them, allowing traffic from the outside worlds to come into a Kubernetes cluster. That's kind of the most basic functionality that is kind of required from a CNI. But then, I mean, Cilium has just grown and grown and grown up the stack to do so much more than that.
Yeah, no, that's a really great take on it. Yeah, Cilium started as a pure CNI for connectivity, but what we've seen in the past few months is it's expanding a number of capabilities, and now it's replacing a lot of tools that people may have used. You know, whether it's for load balancer, service mesh, observability tools, Cilium has become much more than just a CNI. And, you know, if you had to ask me, like, what would I install first in a Kubernetes cluster? I mean, I'm totally biased, but
I mean, you're wearing the t-shirt.
Yeah.
I would say, Cilium will give you address a lot of the networking requirements you have in your cluster.
What makes Cilium better than Calico or Flannel or...
Yeah, how do you differentiate yourself
with
the competitors?
Yeah, it's a very good question. It's always a funny question. I think from my perspective really is Calico was pretty much one of the earliest CNIs that came out. It's been around for quite some time. Very tried and tested. It originally was based upon kind of using routes to get things around. So it was based upon kind of quite simplistic networking technology, but that would allow it to be flexible to a certain degree and things like that. Cilium went down a completely different path. It didn't opt for using existing network technologies. They invented effectively their own way of doing things, and all of that is based upon eBPF to do all of that sort of stuff. So removing the need for modifying kind of routing tables or playing with routing tables, getting rid of IP tables, which everybody is so thankful for.
Some people.
He's the old school guy.
I'm old school guy. I like IP tables, but yeah.
I mean, if you type IP tables -L on a Kubernetes cluster, you can go get a cup of coffee and some lunch and come back.
Yeah.
And it will still be printing out rules at that point. So, I mean, speaking of like IP tables, one of the biggest things that we focused on fixing was really kind of scalability. So the problem that you have from that kind of methodology is every time you add a new rule in or a new pod kind of comes up or a new service, all nodes suddenly need to have all of their IP tables rules updated. And then whenever traffic is moving around, all of those rules need to be inspected before the packet can kind of move on and stuff like that. So when you start to hit big scale and things like that, a lot of those original solutions just kind of creaked and started to kind of fall over. They just weren't kind of capable of doing those sorts of mega scale. So Cilium opted for a different path in how they approached the networking based upon eBPF, removing the requirements for those older technologies and things like that. So I think...
How do you do routing then? How do you know that a pod with an IP is on a different node?
So
Yeah.
eBPF is effectively powering a lot of that. So when a packet is... so we use eBPF for everything that we do at Cilium, pretty much. And that's not just Cilium, the network stack. That's also from observability and from security as well. But effectively, we have eBPF programs that hook into all parts of the system, mainly the networking stack when we're thinking of Cilium. And as a packet traverses the NIC driver in most cases, that's what we tend to hook in. It's called XDP for people interested in these sorts of things. We either hook into XDP or TC. Either way, when the packet comes in, we will see that packet. We will look at the IP headers. We will look at the TCP or UDP that's actually in there. And we will do a map lookup, which means we'll immediately be able to find out if we actually care about that packet. If we do, then we will modify that packet in order to either send it somewhere else, to load balance it to somewhere else. We will potentially, if the packet needs to go to another node, we will encapsulate it. So it will go across a tunnel where it'll hit the other node. It will be de-encapsulated. It will then go to where it actually needs to go. So it's eBPF under the covers, which is running in the kernel that is watching for everything that happens inside the system. And because we don't rely on IP tables or anything like that, it's incredibly fast lookup. We can offload a lot of things to the network card itself as well. So the CPU in a lot of cases doesn't actually need to do any work. The network card's actually doing some of the work in that, and we're getting just free benefits from that kind of design.
I love how quickly we've gone into the weeds of eBPF.
He's wearing that shirt, so that's why.
Sorry about that.
No, it's fine.
It's interesting, and I think I guess I will put the argument out there that you don't actually have to know eBPF to use Cilium, right? That's a secret sauce that powers Cilium and makes the magic happen. But I don't have your eBPF knowledge, but I love what Cilium can do for me.
I think we've almost done ourselves a bit of a disservice because I think people think they need to know eBPF and they don't need to care about it at all. Like we tell everybody it's powered by eBPF because we like talking about eBPF. We kind of invented this.
Yeah.
eBPF. But people who use Cilium and Tetragon and Hubble don't really need to know. They don't need to care to a certain degree. Like it's all kind of taken care of for you.
So for people that are starting with Kubernetes, what's the difference between a CNI and a service mesh?
I guess CNI is designed to give you that, the connectivity, right, between your pods, to give your pods an IP addresses. That's more like the essential connectivity layer. It's a CNI, I guess, is by default is supposed to be more like the specification or how networking should be done in containers. And then we talk about CNI plugin more. We call them CNIs really. So like we see like Flannel, Calico, and Cilium. But again, it was more designed for connectivity. And then for the more advanced networking and security observability capabilities, we thought, okay, we're going to need something like a service mesh. But the reason behind the creation of a service mesh was that initially we went from a monolith architecture. We had one big application to microservices. And microservices were all written in different code, right? You can have a microservice in Go or one in Java. But you needed to be able to connect these microservices together, right? And apply some kind of networking logic. So what people initially started with was to write that networking logic in Go and then do the same in Python. So there was a lot of efforts just writing networking code in different programming languages. So the first approach to solving that problem was to put a little proxy in a sidecar container, which will be responsible for all that networking. So you kind of decouple that networking in business logic out of your application container into a dedicated
Like an envoy container.
Envoy, exactly. So Envoy was like the most popular, it remains the most popular proxy to essentially do a lot of the intelligent routing, rate limiting, load balancing between your different microservices. Now, that worked fine, but one of the challenges is that for each pod, you needed to have this kind of sidecar proxy to do your networking for you. So you essentially double the amount of pods in your cluster.
Mm-hmm.
And it's like, if you think about the networking world, it would be like putting a router in front of every server. That's pretty much the same thing. So eventually, Cilium came out with a Cilium service mesh, where, again, by using eBPF, we were able to do a lot of the networking magic without having to install the sidecar. So it became far more efficient to be able to connect all your microservices, but without having to double the number of containers in your cluster.
Okay. But you're still using an envoy on the machine?
Yeah, so we, instead of having one envoy per pod, we essentially have one envoy per node. So
Is it a little bit what I see with the Linkerd and with Istio doing with the ambient mesh?
yes. So, I mean, I think it's fair to say that Cilium kind of started the sidecar-less approach. And then the Istio team decided to realize this was a fair, like a good approach, right, to reduce the resources that so many micro proxies would use. So they went down the ambient route, and again, the more good, elegant solutions, the better, right?
Bij ACC/ICT staat alles in het teken van continuïteit waarborgen voor bedrijfskritische applicaties. Of het nu gaat over Managed OTAP, Cloud en Kubernetes, ze geven hier invulling aan om door samen met hun klanten een toekomstbestendige strategie uit te stippelen voor het gehele proces van ontwikkelen tot en met productie.
What makes Cilium the best CNI in the world?
What makes Cilium, from my perspective, the best really is the approach that we've taken to grow functionality in a Kubernetes cluster. So, as you know, like the first question you kind of asked me was, what is Cilium? And it started as a CNI. It was there to provide basic networking Kubernetes pod service, etc., so on and so forth. And you can start with that. If you're doing a new cluster, that's kind of where you want to begin. But as you mature and start to do more things with it, and you need more functionality, you have previously you had the option of looking at the CNCF roadmap and your head would explode because where do I even go from here?
Yeah,
there's so many different projects out there, and which is the right one for me and things like that. With Cilium, it is a case now of you can effectively just start to enable and turn on more and more features as the requirements change and your things mature, your programs, the applications have more requirements and things like that. So you can start as just a CNI. You can then start to use things like service mesh by turning that on. You need more insight into what's actually happening within your Kubernetes cluster from a networking perspective. So you want some observability. The Cilium CNI, Cilium enable Hubble or Hubble enable, all of a sudden now we have an additional service that's running which will plug into Cilium and give us insight into everything that's happening from a networking perspective. So all of a sudden, we get all the network information that's plugged into the Kubernetes API. So it's not just random IP addresses flying around. It's actually telling me that this pod is trying to speak to the outside world, or this pod is trying to speak to this service. So, I mean, I'm just getting fantastic insights and building upon just that CNI, and I can start to go,
okay,
there's no limits.
And you're talking about Hubble?
Yes.
What is Hubble?
Yeah, so Hubble is like the observability component that comes with Cilium. And again, it uses the, hooks into the Linux kernel using eBPF, inspects the traffic. It's like the next version of TCP dump, if you like, or if you're more for networking people, it's like NetFlow or SFlow, which can give you this kind of insight into traffic.
So if I make network policies, because we need to make network policies,
Yep.
I hope everybody makes network policies. It's a bit of a thing.
Yep.
I think in Kubernetes, because if you make a namespace and pods and another namespace with pods, you can reach each other.
Yep, yeah.
That's so we need to make network policies, but the normal network policies, if you make them, they're not. If they drop traffic, you can't see it.
Yeah.
Yeah, but you can't. I think
So Hubble, and one of the things that it's designed to do is to help you with adopting network policies. Because we know it's hard, and it's just same as a network engineer, which is my background, is putting the right security rules on your firewalls. You're being told by a developer this virtual machine or is this physical server is talking to that machine, but they're not always they're not always sure, and things change, right? And it's the same in Kubernetes, right? Creating the right network policies.
it's difficult.
It's hard. Yeah, you can't necessarily trust your developers, right? So no offense, but
No. But that's awesome. And if I build like an AKS cluster or an GKE cluster or an EKS cluster, I'm getting the CNI of that cloud provider. Can I, for example, an AKS cluster, can I put Cilium in there with their support?
yeah, actually, I mean, some of the clusters in the cloud even come with Cilium. And what people actually don't know, if, for example, GKE, if you deploy a cluster, comes by default with Cilium.
Azure has the AKS clusters have their own CNI.
Yeah, Azure also AKS had their own CNI, but now last year they launched something called Azure CNI powered by Cilium. And essentially the direction they're going is that, especially for like large clusters with requirements for like security, encryption, they recommend use their embedded Cilium version. And so new cluster, you can deploy them by default on AKS, fully supported using Cilium. And it's because you asked before about why is Cilium the best CNIs? Well, you should maybe ask the cloud providers, because they looked at all the the landscape of CNIs. Google picked Cilium, Azure picked Cilium, Amazon, when they built EKS Anywhere, which is a distribution of EKS, they picked Cilium as well. So. And you can look at lots of the different providers that are now using Cilium as the default CNI that comes out of the box for their clusters.
Oh, that's awesome. That's awesome. If I build, you're talking about big clusters. We had a podcast about Reddit. Reddit had a breakdown with Calico, because Calico uses routing tables. If you build a big cluster, you need specific nodes who route. Otherwise, the Kubernetes cluster is routing everything, and it's going to be big routing tables, and there are a lot of problems with that. But where are your limitations of Cilium? Can I build a cluster with 10,000 nodes?
Yeah, good luck hitting the limits. No, I mean
you don't have to do any special like for Calico. You need routing nodes. Do I have to do something specific to support more than like 1,000 nodes? Or it's a big number.
I think we have a number of case studies that's from likes of trip.com, which is like the Chinese transport with hundreds of nodes, thousands of nodes and clusters. Datadog, the New York Times, just the sheer scale numbers are just hard to even.
Yeah, there's nothing specific that needs kind of fine tuning, I don't think. Generally, out of the box, it's going to support large scale amounts of numbers, and going around, it's not going to hit, because it's a lot of the things are really dependent on rewritten, effectively, a lot of the stack for doing all of the clever network manipulation. We don't really need to do any kind of fine tuning in the kernel to enable this, that, and the other. One of the issues that used to happen quite a lot as well was if you were running other things that would play with IP tables, that would break things like Calico, because Calico is continuously injecting IP tables rules. You may have some sort of different type of service mesh that's also injecting IP tables rules. If they're not being inspected in the right order, things would suddenly break and traffic would go to the wrong place and things like that. We can ignore all of that because we're seeing the traffic before anything else is. So we've just hijacked, effectively, everything that's happening to move away from those limitations.
Oh, that's awesome. But then what are the limitations? Are there limitations?
It's a good question. I mean, at the moment, I think we are seeing what's kind of happening. We kind of get trying to think what generally the requests are that most people kind of have that we're kind of struggling to fulfill at the moment. And from a CNI perspective, kind of moving the packets around is done. Like, yes, that, and I mentioned we don't tend to have issues with scale from that perspective. It's now we're starting to see more advanced use cases and things like that. A lot of people are wanting to start to do more kind of application awareness, growing more into the service mesh side. We can have Istio. We can kind of do more stuff directly within eBPF at the moment and things like that. There are limitations to what we can do in eBPF due to the way that actually works. So we still sometimes do need to use things like Envoy, or we may need to use Istio and things like that. I think as that technology matures, we may be able to move more and more things into eBPF and get the benefits of doing everything in kernel, low latency. So in terms of limitations, it's not really limitations. I think it's just we're still kind of realizing what features are being asked for and what we kind of need to focus on.
As a platform, we still have a long ways to go, actually, because I think we can still make Cilium easier. It's easier to install, configure, and manage. When we've been in the Cilium ecosystem for a little while, it kind of maybe takes things for granted, but I think there are many people that are still like discovering Cilium Kubernetes. And
Kubernetes is difficult, and then Cilium is more difficult on top of that.
Yeah. Somebody came up to me at the booth the other day and was saying that they're building some new environments and they wanted to use Cilium, and they're asking me a bunch of questions, but they said they found it scary, and I couldn't really understand why they felt that way. I don't know if that's just so not brainwashed. I live the Cilium world, and kind of it's
yeah. And I think that's why people maybe start with using like Flannel in their home labs, right? Because
it's flat.
Yeah.
It's phase-LAN.
Yeah.
It's easy.
Yeah. So I think we still have a job to do to make it easier for people to consume and install. But we're getting there. Cilium comes with a CNI, that's the Cilium CNI, where that helps you optimally implement and install Cilium. It would automatically work out that, okay, this is a EKS cluster, or that's a kind cluster, or that's a GK cluster, and then deployed according to the underlying platform. But still, there's a little ways to go before. It should be more like a click of a button, right? It should be boom, you're Cilium ready now.
So can we run small clusters? You talked about kind. We had kind on the podcast some time ago. You can put Cilium also in a kind cluster.
Yeah, no, absolutely. It's you can run Cilium on Can, you can run Cilium on home labs. We did a live stream back in October with a couple of my colleagues that had deployed Cilium in their home labs. And it was not just for CNI, but it was also for an Ingress Controller.
Okay.
So
how does that work? And Cilium is an Ingress Controller.
Any other Ingress Controller or like Gateway API. So actually, we were using Gateway API, which is a successor to the Ingress.
Yes.
And what they were doing is they were running games on their gaming rig on their internal home labs, and they were exposing the games through Gateway API. So we were playing Quake. If you ever played the shooting.
Yeah, we know Quake.
Competitively, so I know.
Yeah.
I remember the podcast you were doing because you were trying to talk, but you were also still playing Quake at the same time. And I was watching you play. I was watching the Echo session that you were doing, so I started suddenly playing Quake as well. So he was trying to talk away, and I kept killing him, and I could see him getting more and more annoyed. Just talking.
I was trying not to swear while presenting a eBPF program, but so. Yeah, I mean, Cilium, again, it's, I think we're trying to make it more accessible to people. And because some of these, home lab users had been using Flannel, had been, installing a service mesh, had installed an Ingress, and now Cilium was doing everything for them.
And because home lab users don't have power of the clouds, and they need to allocate, if you allocate your external IP addresses, so if you give your service load balance attack, you need to add like a MetaLB or something else to allocate your IP addresses on the outside to get in your clusters. How does Cilium solve that?
So a year ago, we used to bundle MetaLB as part of Cilium.
I think MetaLB is awesome, but
but we don't do that anymore.
No, I read that. That's
as of 1.13.
Yes.
Yeah, we added both layer 2 announcements and BGP peering.
Okay, cool.
And all of that is, so the BGP peering is all powered by the Go library, Go BGP, which is one of the more popular networking libraries packages that's part of the Go ecosystem. So all of that now allows Cilium to peer with top-of-rack routers or whatever, like in your home environment. If you're running things like Unify equipment and things like that, which a lot of home labbers tend to do, you can BGP peer now, and you do that with those. And if not, you can do layer 2 announcements where an IP address will be assigned to a node, and then you'll broadcast to the rest of your network that this MAC address is where this IP address lives. So the rest of your network now knows to send traffic, when I need to access that IP address, what piece of hardware to go to. So,
And if that node fails, what happens then?
the address will move over. So it'll do leader election under the covers to determine which one should host. 'Cause you can only have a one-to-one mapping of MAC address to IP address.
Yeah.
If not, things go very weird. So that's where we do a leader election. If that node fails, a new leader election will occur. One of the nodes will be chosen as the leader. That node will then do a gratuitous ARP broadcast, which is, I now host this IP address and my MAC address is this. The rest of the network is updated, and now it knows where to send traffic to the IP address.
Cool.
Yeah.
Yeah.
No, I love getting very low level into networking.
Yeah.
So yeah, that's really cool because a lot of people use on-prem and the BGP stuff. That's fully compatible with upstream or BGP. Yeah.
It's so funny. When I joined Isovalent 2 years ago, I went to KubeCon a couple of months after joining, and we'd done the BGP functionality added to Cilium. And I spent 3 solid days being asked BGP questions. I was like, what year is it? It was crazy. Yeah, so we adhere to the BGP standards. We send the BGP messages. We publish routes to top-of-rack switches. So the rest of the network now knows if I need to send traffic to this IP range, send it to one of these nodes, and then the route to the kernel will know to send traffic to where it needs to go on that node. One thing that we've not added, though, is publishing routes back in. So we can push routes out.
Okay.
So the rest of the network knows. We are now getting requests for people asking for routes being pushed in the opposite direction. And the other thing as well is BFD. So being able to do super fast failover.
Yeah.
At the moment, if a node dies,
Yeah.
it's the timeout on the BGP messaging before that route is then removed from the top rack switches.
Yeah, I'm asking for myself. Right?
Yeah, I was looking at you. That was fine. Yeah, a question what popped into my head is because he talks about game. I am hearing about routing traffic. We had Mark Mandel from Google in a podcast, and they are specialized with Agonis and game servers in Kubernetes. And they are working on a project called Quilcane, and that's UDP routing for game services. So,
Okay.
is that something Cilium also supports, UDP routing or that kind of stuff?
Well, for the gateway APIs, implementation of Cilium will support UDP routes into the cluster, which will be a way to access your.
Yeah, you triggered something with me.
And from standard services at the moment, it's TCP, UDP, or SCTP. So all of that is supported. So you can all of that type of traffic is supported both by Cilium and Kubernetes services within there. The Gateway API project, which we're now heavily investing in.
Our listeners probably not.
Okay.
Yeah.
So yeah, kind of quite quickly, I suppose the concept is to break things down to make it easier for responsibilities to be given to application owners. They don't need to deploy services and things like that. Network person or somebody with the right privileges will create a gateway. The gateway has the IP address on it. That's the way into the cluster. We attach then routes to that gateway. The main one that everybody's been focused on is the HTTP route, Ingress Controller, basically. So HTTP route would be /yellow, and the backend service that is attached to that HTTP route. That's all 1.0. That's all released. Everybody's now using that quite happily. What we're now looking at adding is TCP routes and UDP routes. They're still beta at the moment, but effectively they're going to replace, or the plan is that they're going to replace services at some point in the future.
Oh.
Because the problem is that a Kubernetes service is so overloaded in what it does. So we're trying to break all those things down. And as I mentioned, the responsibility is that the application owners will create those routes, whether it's a HTTP route or a TCP route.
Yeah.
They don't care about the gateway. Somebody else takes care of all of it.
Yeah, of course. That's awesome. Yeah. But you're replacing services. That's an intricate part.
I mean, yeah. I spoke to one of the core developers of Gateway API, one of which is also Nick Young, who's part of Isovalent as well. So we have heavy investment in it. But yeah, will services ever go away? Probably not. There's deprecated tags all over Kubernetes that never means the things are deprecated, but they're never going to go anywhere.
But it's an intricate part. It's Kubernetes.
Yes,
Kubernetes are pods and services. That's the main thing.
Yep.
Yeah.
I mean, it's a lofty goal for the Gateway API project.
Yeah.
Whether it will occur or not is not my decision. But the idea is that if they do get to a point where it makes sense, then services will hopefully wither away and go away, and everything will be all Gateway API as your entry point into a Kubernetes cluster.
Cool.
We have another question, Jan.
No, I've got a last question.
No. Oh, the last question, guys, to wrap things up. How do you see the future of Kubernetes?
I'm seeing a couple of different trends. One,
Services are going away.
and I will intentionally not say I'm actually think people are tired. I think people are exhausted by the overwhelming amount of tools and you look at this, as you mentioned, the CNCF landscape, right? It's overwhelming. It's just, and the CNCF accepts a lot of projects, and it encouraging open source, which is great, but also I think that's just causes a lot of fatigue with which one should I use. And I think there is going to be, I already see some of the sessions at this week, people trying to maybe consolidate the amount of tools and just trying to simplify and standardize. People don't necessarily want more features actually.
But if you go in on the floor, and I don't know if you have seen how many boots here are.
Yeah, I mean, people have invest time and money into these projects, but put yourself in the perspective of the user. I actually don't think the users want necessarily more features. They just want to be able to build clusters, secure clusters, automate things, but they just want to simplify things. And I think that's one of my observations. And the only other thing I see is also integration with the old world, if you like. It's also the perception.
He's pointing at me, by the way.
No, I think there's a perception that Kubernetes is great, it's everywhere, but you probably have still 80 million virtual machines that are there. You have bare metal servers, and we still need to get all these systems to talk to each other. So there's going to be more of a move towards heterogeneous networking and connectivity, just trying to connect your old stuff with your cloud native stuff. Right? And that's because migrating, we know how painful migrating is. We have mainframe stuff, running. So now I think the focus will be on connecting the cloud native to the older stuff. Yeah.
Something to add, Daniel?
No, I think from my perspective, that kind of hits. There is fatigue. There is a lot of people who are they adopted projects a long time ago when they were originally building these clusters, and they're worried now about the lifespan of these particular projects. How do I replace it? How do I find a healthier alternative and things like that? There's been a lot of turmoil in the industry recently as well. A lot of projects now are losing maintainers, or people have had to move to different roles where they may not have the time to maintain these projects and things like that. I think the CNCF are now starting to adopt slightly more robust archiving on some of the projects that are part of things like the sandbox, and Open EBS was archived recently because the maintainers just didn't have time to actually respond and keep things up. And so there's a bit more due diligence happening, but I think people are saddled a little bit with technical debt from decisions that were made a few years ago in some of their clusters. To Nico's point as well, we're starting to see these clusters that were built by devs now being handed to networking teams and
operations.
And it's what's this? Where'd this come from? So traditional networking engineers are none of my tools are work on. What's this network? Where'd that come from? I can't see this network. It's inside your your cluster and this, that, and the other. So we are trying to educate networking engineers in the world of Kubernetes networking and the concepts of pods and services and ingresses and things like that. So there's those are additional challenges. I think finally for me as well, and you mentioned Craig Box earlier, he tweeted a week or two ago about rewriting Kubernetes in eBPF, which I thought was funny, but then it got me thinking.
Home projects.
Well, yeah, so it was kind of funny, but I mean, I started speaking to a few other people in the eBPF community, and it's like, well, we could probably start to do some stuff around that. So I don't know. I'm kind of enthused about what we may or may not be able to do with eBPF in maybe replacing bits of Kubernetes just to make people's lives more complicated, I suppose. But yeah, I it's nice that things we're simplifying. Hopefully, we're starting to simplify things. The Cilium project simplifies a lot of things by reducing the amount of tooling. The CNCF projects are doing a bit more housework in terms of being able to show healthier projects, which hopefully make people's lives a bit easier in selecting things. So I'm kind of enthused a little bit more now about how things are going. It's hopefully simplifying and making people's lives a bit easier as we move forward.
Cool.
Fingers crossed.
Yeah, I think that's a good thing. Cool. Now, thank you very much for your time.
Thank you for having us.
Thank you.
Yeah.
It's been a pleasure.
Yeah, we're going to follow the development of eBPF Isovalent.
That's right.
I tried to pronounce it correctly this time. With great interest. So thank you again, and I hope to see you again in the future.
Likewise.
Deze podcast is een initiatief van ACC ICT en wij zijn te beluisteren op onze website k8spodcast.nl via Spotify, Apple, Google Podcast en alle andere favoriete podcastproviders.